As humans, one of the first things that we learn is cause and effect. Whether it be, I've got a Fisher-Price toy, I press the button, it makes a squeak noise. As a baby, you suddenly realize that certain things happen as a reaction to something else happening, or as a consequence of something else happening first, whether it's something you've done or something somebody else has done. This cause and effect is basically what programming is, and trying to teach very, very young children about programming, you can basically build on this same cause and effect that you originally started with when you didn't realize that you were teaching them programming. When you write a line of code and give it to a computer, what's actually happening is you're creating the cause and running that code is the effect. If you tell the computer to go and beep at a certain frequency, that's the cause, and the effect will be that you will get the beep at the frequency you specify. On top of the cause and effect, there is also the idea of how do you compile these causes to create a program? If you have enough causes in sequence, that's called an algorithm. It's do this, do this, do this, and what will happen when it runs is you'll get this output, this output, this output. Most children don't understand how to write a programming language, but what they do understand are the fundamentals that make up a programming language. We teach children already what those fundamentals are, we just don't attach the label to it. Take something like an if function. Kids know this. If there is a movie on TV that I want to watch and I've been a good boy, I can watch the movie. Else, I am not watching the movie. As parents, we use this logic all the time. If you tidy up your room, you will have this treat. Else, no treat for you. So the children already understand the logic. What they don't realize is how this logic is written down, and that's what a programming language is. Now, as well as a standard if statement, there are things like ands and ors and nots. These are all logic gates on a circuit board. These are also things that children fundamentally understand. We just haven't attached the logic tag to it from programming. So a classic example of a not is do not do that. Whatever it is you're doing, stop it. That is very, very simply what a not is. If there's an input that is true, it comes out false. If it goes in false, it comes out true. Very, very basic. Or take something like an or. So you can have this treat or that treat. That's an or gate. If you have an exclusive or, well, you can have one treat or the other treat, but not both. Again, children understand this as low as like 2 years old. And as adults, we all understand this. But again, if nobody tells you that this is actually how electronics works, the average adult is going to have a hard time trying to link the two together unless you actually point it out to them. I started teaching our children to program when they were 3. As time has gone by, we've slowly moved up into Scratch, and we use Scratch to program games and do other small projects that aren't too taxing for the kids, but at the same time allows them to see that the cause and effect is something that they actually do already understand. We don't do anything that they don't already understand. The only thing that limits what they do at the moment is literally their ability to read and write. The problem is not the logic side, it's literally, typing at the keyboard and reading what they've written. I'm going to finish off on this part, just basically saying that this is what I have been doing. It's important to not overstretch a child with too much information at a very, very early age. In the same way that a child can run and walk, and you just haven't tied, for instance, the tag field and track or athletics to it, they already know how to do the thing that they're going to be asked to do when they come to do field and track or athletics. It's just a label and a construct. Instead of just running willy-nilly, you now run from this start line to that finish line. And programming is pretty much the same thing. You can start off at a very, very basic level with some very, very basic constructs, and the child already knows those constructs and knows how those pieces fit together and cause and effect. What they don't know is that's what a programming language is, because nobody's ever tied that term to it. So I'm going to leave it off there for this part and let you digest that. But that's what I wanted to cover today. Bye.